Black holes are not just cosmic anomalies, they are the ultimate enigmas of the universe, bending the very fabric of reality as we know it. Imagine a place where time slows to a crawl, where light itself cannot escape, and where the laws of physics, as we understand them, begin to unravel. These mysterious giants of the cosmos challenge everything we think we know about space, time, and existence itself. But what if I told you that black holes are not just destructive forces? They might hold the keys to understanding the universe's deepest secrets. Today, we're diving into the 15 most astonishing facts about black holes, facts that will stretch your imagination, challenge your assumptions, and leave you in awe of the cosmos. From their mind-bending ability to warp space-time to the strange phenomena that occur at their edges, this journey will take you to the very limits of human understanding. And it all starts with a fact so incredible, it might just change the way you see the universe forever. Ready to explore the unknown? Let's begin. You might think of black holes as empty, bottomless pits in space, vast, dark voids where nothing exists. But here's the astonishing truth: black holes are anything but empty. In fact, they are some of the most densely packed objects in the universe. At the heart of every black hole lies something called a singularity, a point where an unimaginable amount of mass is crushed into an infinitely small space. Think about it, the mass of entire stars, sometimes even millions or billions of times the mass of our Sun, squeezed into a single point. It's this incredible density that gives black holes their mind-blowing gravitational pull, so strong that not even light can escape its grasp. Take Sagittarius A, the supermassive black hole at the center of our Milky Way galaxy. It's estimated to have a mass 4 million times that of our Sun, yet it's all concentrated into a space smaller than our solar system. That's like cramming millions of suns into a cosmic pinprick, and it's this immense mass that shapes everything around it, from the orbits of nearby stars to the swirling disks of gas and dust that spiral into its depths. But here's the kicker: this mass doesn't just sit there. It warps the very fabric of space-time, bending light and distorting reality itself. And that's just the beginning. The way black holes interact with their surroundings is even more fascinating, but we'll get to that in just a moment. Now, let's talk about one of the most bizarre and mind-bending effects of a black hole's gravity: spaghettification. Yes, you heard that right, spaghettification. It's not just a fun word to say, it's a real phenomenon that happens when you get too close to a black hole. Imagine this: you're floating in space, minding your own business, when suddenly you drift a little too close to a black hole. At first, you might not notice anything unusual, but as you inch closer, something strange begins to happen. The black hole's immense gravitational pull starts to stretch you literally. Here's how it works: the side of your body closest to the black hole feels a much stronger gravitational pull than the side farther away. This difference in force, known as tidal force, starts to stretch you out like pulling on a piece of taffy. Your body gets longer and thinner until eventually you're stretched into a long, thin strand like a piece of spaghetti. It's a gruesome thought, but it's also a fascinating demonstration of just how extreme the forces around a black hole can be. And it's not just you. Anything that gets too close, whether it's a star, a planet, or even a spaceship, would undergo the same fate. The closer you get to the event horizon, the point of no return, the stronger the stretching becomes. It's like the black hole is playing a cosmic game of tug-of-war with your very atoms. But here's where it gets even stranger. Black holes don't just distort matter, they also warp time. As you approach the event horizon, time itself begins to slow down. To an outside observer, it would look like you're moving in slow motion, almost as if you're frozen in time. But for you, time would feel normal, right up until the moment you're stretched into a cosmic noodle. This combination of spaghettification and time dilation makes black holes some of the most extreme environments in the universe. They challenge our understanding of physics and force us to rethink what we know about space, time, and reality itself. And as we'll see next, the effects of black holes go far beyond just stretching and warping. They can also create some of the most spectacular phenomena in the cosmos. Now, let's take a step into the realm of time itself, because near a black hole, time doesn't just slow down, it practically grinds to a halt. This mind-bending phenomenon is one of the most striking predictions of Einstein's theory of relativity, and black holes are the ultimate testing ground for it. Imagine you're an astronaut floating in space and you decide to take a daring plunge toward a black hole. As you approach, something strange happens. Time begins to stretch. For you, everything feels normal. You're falling, yes, but your watch ticks at the same steady pace it always has. But for someone watching you from a safe distance, it's a completely different story. To them, you're moving in slow motion, as if you're stuck in a cosmic time warp. The closer you get to the black hole's event horizon, the slower you appear to move, until, from their perspective, you seem to freeze in place entirely. This isn't science fiction, it's science fact. Einstein's theory of relativity tells us that gravity doesn't just bend space, it bends time too. Near a black hole where gravity is at its most extreme, this effect becomes dramatic. The immense gravitational pull warps time so much that it creates what's known as time dilation. For every second that passes for you, the astronaut falling into the black hole, years or even centuries could pass for someone far away. It's like stepping into a cosmic time machine where the rules of time itself are rewritten. But what does this mean for us? Well, it's not just a cool thought experiment. It has real implications for space travel and our understanding of the universe. If we ever developed the technology to travel near black holes, we'd have to account for these extreme time distortions. A journey that feels like a few hours for the traveler could mean decades or more for those back on Earth. It's a reminder of just how strange and unpredictable the universe can be, and how much we still have to learn. And here's where it gets even more fascinating. Black holes don't just warp time, they also bend light. This bending of light, known as gravitational lensing, creates some of the most stunning visual effects in the cosmos. Imagine looking at a black hole and seeing the light from stars behind it twisted and distorted, like looking through a cosmic funhouse mirror. It's a phenomenon that not only looks incredible but also gives us a powerful tool for studying the universe. So, as we've seen, black holes are more than just cosmic vacuum cleaners. They're time-bending, light-warping laboratories that challenge everything we think we know about the universe. And as we'll discover next, their ability to bend light opens up a whole new world of possibilities for exploring the cosmos. But that's a story for the next factor, and trust me, it's one you won't want to miss. Now let's dive into one of the most visually stunning effects of black holes, gravitational lensing. Imagine you're looking at a black hole, and instead of seeing just darkness, you notice something extraordinary. The light from stars and galaxies behind it is twisted and warped like a cosmic funhouse mirror. This isn't just a trick of the eye, it's a real phenomenon caused by the black hole's immense gravity bending the very fabric of space-time. Here's how it works. Light travels in straight lines, but near a black hole, space-time is so warped that even light can't follow a straight path. Instead, it curves around the black hole, creating a distorted image of whatever lies behind it. Sometimes, this distortion forms a perfect ring of light around the black hole, known as an Einstein ring. Other times, it creates multiple images of the same object stretched and smeared across the sky. It's like nature's own magnifying glass, but on a cosmic scale. One of the most famous examples of gravitational lensing is the galaxy cluster Abell 1689. This cluster is so massive that it acts like a giant lens, magnifying and distorting the light from galaxies billions of light years behind it. Thanks to this effect, astronomers can study galaxies that would otherwise be too faint or distant to see. It's like having a built-in telescope in the fabric of the universe itself. But gravitational lensing isn't just a pretty picture, it's a powerful tool for scientists. By studying how light bends around black holes and other massive objects, astronomers can map the distribution of dark matter, measure the expansion of the universe, and even test the predictions of Einstein's theory of relativity. It's a window into the hidden workings of the cosmos, and black holes are at the heart of it all. And here's where things get even more fascinating. Black holes, despite their reputation for being dark and destructive, can also emit energy. Yes, you heard that right, black holes aren't just cosmic vacuum cleaners. They can also be cosmic powerhouses. But how does something that devours light also emit energy? That's a mystery we'll unravel next, and trust me, it's going to blow your mind. Now, let's tackle one of the most mind-blowing facts about black holes. They can actually emit energy. Yes, you heard that right, black holes, those cosmic vacuum cleaners that devour everything in their path, aren't just takers, they're also givers. This incredible discovery comes from none other than Stephen Hawking, one of the greatest minds in modern physics. Hawking proposed that black holes aren't entirely black, they can emit radiation, a phenomenon now known as Hawking radiation. But how does something that traps light and matter also manage to emit energy? The answer lies in the strange and mysterious world of quantum mechanics. Here's the key idea: space isn't empty. Even in the vacuum of space, particles are constantly popping into existence in pairs, one particle and its antimatter counterpart. These are called virtual particles, and they usually annihilate each other almost instantly. But near the event horizon of a black hole, something extraordinary happens. Sometimes one of these particles falls into the black hole while the other escapes. The escaping particle becomes real, carrying away a tiny bit of the black hole's energy. Over time, this process causes the black hole to lose mass and eventually evaporate. It's like the black hole is slowly leaking energy, one particle at a time. Now, don't get too excited. This process is incredibly slow. For a black hole the size of our sun, it would take trillions upon trillions of years to evaporate completely. But for smaller black holes, the process speeds up and they can vanish in a spectacular burst of energy. This discovery turned our understanding of black holes on its head. They're not eternal, they have a lifespan, and they can fade away into nothingness. But here's the kicker: Hawking radiation isn't just a cool theoretical idea, it has profound implications for the fate of the universe. If black holes can evaporate, what happens to all the information they've swallowed? This question, known as the black hole information paradox, is one of the biggest unsolved mysteries in physics. It challenges our understanding of how information is preserved in the universe and whether the laws of quantum mechanics and gravity can ever be reconciled. And while we're on the topic of black holes fading away, let's not forget that they can also grow to unimaginable sizes. In fact, some black holes are so massive they defy comprehension. But how big can they get, and what happens when they reach their limits? That's a story for the next fact, and trust me, it's going to take us to the very edge of cosmic possibility. Now, let's zoom out from the mind-bending physics of individual black holes and take a look at the bigger picture, literally. Did you know that at the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole? These cosmic giants are millions, even billions of times more massive than the black holes we've been talking about so far. And they're not just sitting there quietly, they play a crucial role in shaping the galaxies they call home. Take Sagittarius A, the supermassive black hole at the center of the Milky Way. It's about 4 million times the mass of our Sun, yet it's tucked into a space smaller than our solar system. But Sagittarius A is just one example. In 2019, the world got its first real glimpse of a supermassive black hole when scientists captured an image of the one at the center of the galaxy M87. This black hole is a true behemoth, weighing in at a staggering 6.5 billion times the mass of the Sun. The image, a glowing ring of light surrounding a dark shadow, became an instant icon, a testament to human ingenuity and the awe-inspiring power of these cosmic titans. But how do supermassive black holes form in the first place? That's a question scientists are still working to answer. One theory is that they grow from smaller black holes, merging and consuming matter over billions of years. Another idea is that they formed directly from the collapse of massive clouds of gas in the early universe. Whatever their origins, these supermassive black holes have a profound impact on their galaxies. Their immense gravity shapes the orbits of stars, influences the formation of new stars, and even powers some of the brightest objects in the universe, quasars. These are galaxies with supermassive black holes that are actively feeding, releasing enormous amounts of energy as they devour gas and dust. And here's where it gets even more fascinating. Supermassive black holes don't just sit quietly at the center of galaxies. They can collide, merging into even larger black holes. When this happens, the collision sends ripples through the fabric of space-time itself. Ripples we call gravitational waves. These waves, first detected in 2015, have opened up a whole new way of observing the universe. They allow us to hear the echoes of cosmic events that happened billions of years ago, like the collision of two supermassive black holes. So, as we've seen, supermassive black holes are more than just cosmic curiosities. They're the engines that drive the evolution of galaxies, the architects of the universe on the grandest scales. And as we'll discover next, when these giants collide, they create some of the most dramatic events in the cosmos. But that's a story for the next fact, and trust me, it's one that will leave you speechless. Now, let's talk about one of the most dramatic events in the universe, black hole collisions. Picture this: two massive black holes, each millions or even billions of times the mass of our sun, locked in a cosmic dance. They spiral closer and closer, orbiting each other faster and faster, until boom, they collide. The impact is so powerful that it sends ripples through the very fabric of space-time itself. These ripples are called gravitational waves, and they're one of the most extraordinary predictions of Einstein's theory of relativity. Think of it like dropping a pebble into a calm pond. The pebble creates ripples that spread outward, distorting the surface of the water. In the same way, when two black holes collide, they send ripples through space-time, distorting the fabric of the universe. But here's the thing, these ripples aren't just tiny disturbances. The energy released during a black hole collision is mind-boggling. In fact, for a brief moment, the collision can outshine the combined light of every star in the universe. That's how powerful these events are, and here's the kicker: we've actually detected these ripples. In 2015, scientists at the Laser Interferometer Gravitational Wave Observatory, or LIGO, made history by observing gravitational waves for the first time. The signal came from two black holes colliding over 1 billion light-years away. It was a monumental moment, not just because it confirmed Einstein's century-old prediction, but because it opened up a whole new way of observing the universe. Instead of relying on light, we can now listen to the cosmos, hearing the echoes of events that happened billions of years ago. But what does this mean for us? Well, gravitational waves aren't just a cool scientific discovery. They're a window into the hidden workings of the universe. By studying these ripples, scientists can learn about the nature of black holes, the structure of space-time, and even the origins of the universe itself. It's like having a new sense, one that allows us to explore the cosmos in ways we never thought possible. And here's where it gets even more fascinating. Black hole collisions aren't the only events that create gravitational waves. Neutron stars, supernova, and even the Big Bang itself could have left ripples in space-time. But black hole collisions are some of the most powerful, and they give us a front-row seat to the most extreme physics in the universe. Now, as incredible as black hole collisions are, they're just one way these cosmic giants interact with their surroundings. black holes don't just collide with each other, they can also devour stars, tearing them apart in a process so violent it's almost hard to imagine. But that's a story for the next fact, and trust me, it's one you won't want to miss. Now, let's turn our attention to one of the most violent and spectacular events in the cosmos, a black hole tearing apart a star. This isn't just a cosmic catastrophe, it's a tidal disruption event, and it's as dramatic as it sounds. Picture this: a star minding its own business drifts too close to a black hole. At first, nothing seems unusual, but as the star gets closer, the black hole's immense gravity begins to pull. And not just a gentle tug, this is a force so powerful it can stretch the star like taffy, ripping it apart in a process called spaghettification. Here's how it works. The side of the star closest to the black hole feels a much stronger gravitational pull than the side farther away. This difference in force, known as tidal force, stretches the star into a long, thin strand of gas. As the star is torn apart, some of its material spirals into the black hole, forming a glowing disk of superheated gas around it. But not all of the star's material is consumed. Some of it is flung outward in bright jets of energy, creating a flare so intense it can outshine an entire galaxy for weeks or even months. These tidal disruption events are like cosmic fireworks, and they're not just beautiful, they're incredibly useful for scientists. By studying the light emitted during these events, astronomers can learn about the black hole's mass, spin, and even the composition of the unfortunate star. It's like getting a front row seat to the most extreme physics in the universe. But here's the kicker: these events are rare. A galaxy might experience a tidal disruption event only once every 10,000 years or so. That's why every time astronomers spot one, it's a big deal. In 2019, for example, scientists observed a tidal disruption event in a galaxy over 300 million light-years away. The flare was so bright it was visible even with amateur telescopes. It was a reminder of just how powerful and destructive black holes can be. And while these events are catastrophic for the star, they're also a reminder that black holes aren't just dark, silent voids. They're dynamic, energetic, and capable of creating some of the most dazzling displays in the universe. But here's where it gets even more fascinating. Black holes might not be entirely black after all. In fact, they can emit energy in ways that challenge everything we think we know about them. And that's a story we'll dive into next one that will take us to the very edge of our understanding of the cosmos. Now, let's dive into one of the most intriguing debates in modern physics, the idea that black holes might have hair. No, we're not talking about cosmic wigs or fuzzy exteriors. This is about a fundamental question that challenges our understanding of black holes and the universe itself. For decades, scientists believed that black holes were simple objects defined by just three things: their mass, their electric charge, and their spin. This idea, known as the no-hair theorem, suggests that no matter how complex an object is before it falls into a black hole, all that information is lost forever. It's like a cosmic eraser, wiping away every detail until only these three basic properties remain. But here's the twist: recent theories are challenging this long-held belief. Some physicists now think that black holes might have hair, additional properties that store information about what fell into them. This hair isn't something you can see or touch. It's more like a hidden fingerprint, a subtle imprint left behind by the objects the black hole has consumed. If this turns out to be true, it could revolutionize our understanding of black holes and solve one of the biggest mysteries in physics, the black hole information paradox. So, what's the black hole information paradox? It's the idea that when something falls into a black hole, all the information about it, its shape, its composition, its history seems to vanish. But according to the laws of quantum mechanics, information can't just disappear. It has to be conserved. This contradiction has puzzled scientists for decades, and the idea of black hole hair might be the key to resolving it. If black holes do store information in some hidden way, it could mean that nothing is truly lost, it's just encoded in a way we don't yet understand. This debate isn't just academic, it has profound implications for our understanding of the universe. If black holes can store information, they might hold clues about the origins of the cosmos itself. Imagine being able to read a black hole like a cosmic history book, uncovering the secrets of the universe's earliest moments. It's a tantalizing possibility, and one that's driving some of the most exciting research in physics today. But here's the kicker, we're still a long way from proving whether black holes have hair. It's a theory that's still being tested, and it's pushing the boundaries of what we know about gravity, quantum mechanics, and the nature of reality itself. And as we'll see next, this isn't just about black holes, it's about understanding the very fabric of the universe. So, what does this mean for the future of physics? That's a story we'll explore in the next fact, and trust me, it's going to take us to the edge of what we thought was possible. Now, let's venture into one of the most mind-bending and speculative ideas about black holes. Could they be portals to other universes? Imagine this, what if a black hole isn't just a one-way ticket to oblivion, but a gateway to an entirely new reality? It sounds like something straight out of science fiction, but some of the most brilliant minds in physics have seriously considered this possibility. At the heart of this idea is something called a wormhole, a theoretical tunnel through space-time that could connect two distant points in the universe, or even two separate universes altogether. Think of it like a cosmic shortcut, a bridge between worlds, and here's where black holes come in. Some scientists speculate that the extreme conditions inside a black hole could create the perfect environment for a wormhole to form. If that's true, then falling into a black hole might not mean the end. It could mean stepping into a whole new universe. Of course, this is all highly speculative, and there's no direct evidence to prove it. But the math behind Einstein's theory of relativity does allow for the possibility of wormholes, and black holes seem like the most likely place to find them. After all, black holes warp spacetime so dramatically that they could, in theory, bend it back on itself, creating a passage to somewhere else. Science fiction has long embraced this idea, from the iconic wormhole in Interstellar to the mysterious portals in Stargate. These stories capture our imagination, but they also raise fascinating questions. What would it be like to travel through a wormhole? Would we emerge in a parallel universe or somewhere completely alien? And if black holes really are gateways, could we ever use them to explore the cosmos? But here's the catch. Even if wormholes exist, they'd be incredibly unstable. The intense gravitational forces inside a black hole would likely tear apart anything or anyone trying to pass through, and that's assuming you could survive the journey in the first place. So, while the idea of black holes as portals is thrilling, it's still firmly in the realm of theory for now. And speaking of theory, let's not forget that black holes might have another cosmic role to play. What if they're not just gateways but also cosmic recyclers? Imagine a black hole as a giant cosmic blender, taking in matter and energy and spitting it back out in new forms. It's a concept that ties into the idea of black holes as engines of creation, not just destruction. But how does that work? That's a story for the next factor, and trust me, it's going to take us even deeper into the mysteries of these cosmic giants. Now, let's shift our focus to one of the most fascinating and dynamic aspects of black holes, their ability to recycle matter. You might think of black holes as cosmic vacuum cleaners, sucking in everything around them and leaving nothing behind. But here's the astonishing truth: black holes aren't just destroyers, they're also cosmic recyclers. When matter falls into a black hole, it doesn't just vanish. Instead, it forms something called an accretion disk, a swirling, superheated ring of gas and dust that orbits the black hole at incredible speeds. Imagine a cosmic whirlpool, spinning faster and faster as it gets closer to the center. The friction and heat within this disk are so intense that it glows brightly, often outshining entire galaxies. But here's where it gets even more incredible. Not all of this matter gets swallowed by the black hole. Some of it is flung outward in powerful jets of energy, traveling at nearly the speed of light. These jets can stretch for thousands, even millions of light years, carving through the cosmos like cosmic blowtorches. Take quasars, for example. These are some of the brightest objects in the universe, powered by supermassive black holes at the centers of galaxies. As matter spirals into the black hole, it releases an enormous amount of energy, lighting up the surrounding space. The jets from these quasars can influence entire galaxies, shaping the formation of stars and even triggering the birth of new ones. It's like the black hole is a cosmic engine, driving the evolution of the universe itself. But how does this recycling process work? It all comes down to the extreme physics near the black hole. As matter falls in, it's compressed and heated to unimaginable temperatures, releasing energy in the form of light, X-rays, and even gamma rays. Some of this energy is channeled into the jets, which blast outward with enough force to push gas and dust across vast distances. These jets can even create shock waves, triggering the collapse of gas clouds and sparking the formation of new stars. And here's the kicker: this process isn't just a one-time event. Black holes can recycle matter over and over, creating a cycle of destruction and creation that shapes the cosmos on the grandest scales. It's a reminder that black holes aren't just endpoints, they're also catalysts, driving the evolution of galaxies and influencing the fate of the universe itself. But what does this mean for the ultimate fate of the cosmos? Could black holes hold the key to understanding how the universe will end? That's a question we'll explore next, and trust me, it's going to take us to the very edge of what we thought was possible. Now, let's dive into one of the most intriguing mysteries of the cosmos: dark matter. You've probably heard of it, this invisible, elusive substance that makes up about 85% of the matter in the universe. We know it's there because of its gravitational effects, but we've never directly detected it. So, what is it? Well, here's a fascinating theory. What if dark matter isn't made of exotic particles, as many scientists believe, but is instead made of black holes? Specifically, primordial black holes, ancient relics from the very beginning of the universe. Imagine this: in the first moments after the Big Bang, the universe was a seething, chaotic soup of energy and matter. In this turbulent environment, tiny fluctuations in density could have caused pockets of matter to collapse under their own gravity, forming black holes. These wouldn't be the massive black holes we're familiar with today. They'd be small, perhaps no bigger than an atom, but incredibly dense. And here's the kicker: if enough of these primordial black holes formed, they could account for the mysterious dark matter we've been searching for all along. But why is this idea so compelling? For one, it solves a major problem in physics. If dark matter is made of particles, why haven't we detected them yet? Primordial black holes, on the other hand, would be nearly impossible to spot directly. They're too small to emit significant radiation, and they don't interact with light or other forms of electromagnetic energy. They'd be invisible, just like dark matter, and here's where it gets even more fascinating. These primordial black holes could still be out there, drifting through the universe like cosmic ghosts. They could be passing through our solar system, even through Earth itself, without us ever noticing. But how would we detect something so elusive? Scientists have proposed some clever methods, like looking for the gravitational effects of these black holes as they pass in front of distant stars, causing a brief flicker of light known as microlensing. But here's the twist: if primordial black holes do exist, they're not just dark matter candidates, they're also time capsules. These ancient objects could hold clues about the conditions of the early universe, offering a glimpse into a time long before stars and galaxies even existed. They could help us answer some of the biggest questions in cosmology. What was the universe like in its infancy? How did it evolve into the cosmos we see today? And what role did black holes play in shaping it? So, as we've seen, black holes might not just be the ultimate cosmic vacuum cleaners. They could also be the key to unlocking the mystery of dark matter and the origins of the universe itself. But what if black holes could do even more? What if they're not just time capsules, but also cosmic storytellers, preserving the history of the universe in ways we're only beginning to understand? That's a story for the next fact, and trust me, it's going to take us even deeper into the mysteries of these enigmatic giants. Now, let's tackle one of the most perplexing mysteries in physics, the black hole information paradox. Imagine this: what happens to all the information about an object when it falls into a black hole? Does it just vanish, erased from existence forever? Or is it somehow preserved, hidden in a way we don't yet understand? This question isn't just a philosophical puzzle, it's a fundamental challenge to our understanding of the universe. Here's the problem: according to the laws of quantum mechanics, information can't just disappear. It has to be conserved. Think of it like this: if you burn a book, the information in it isn't truly lost. The words might be gone, but the atoms and energy that made up the book still exist, just in a different form. But black holes seem to break this rule. When something falls into a black hole, it's gone, seemingly forever. The information about what it was, what it looked like, and how it behaved appears to vanish into the singularity. This contradiction is what we call the black hole information paradox, and it's been keeping physicists up at night for decades. But here's where it gets fascinating. Some theories suggest that the information isn't lost after all. One of the most intriguing ideas is the holographic principle. This theory proposes that all the information about what falls into a black hole isn't destroyed. It's encoded on the black hole's event horizon, the boundary beyond which nothing can escape. Think of it like a cosmic hard drive. The event horizon acts as a two-dimensional surface that stores all the information about the three-dimensional objects that fall into the black hole. It's like taking a 3D movie and compressing it onto a 2D screen. The information is still there, just in a different form. This idea is mind-bending, but it could solve the paradox by showing that information isn't lost, it's just transformed. And here's the kicker: if the holographic principle is correct, it could revolutionize our understanding of not just black holes, but the entire universe. It suggests that the fabric of reality itself might be a kind of hologram, with all the information about the cosmos encoded on its boundaries. It's a radical idea, but one that's gaining traction among physicists. But what does this mean for black holes? Well, it suggests that they're not just cosmic vacuum cleaners, they're also cosmic archivists, preserving the history of everything they've ever consumed. And that's not all. Black holes might also be cosmic engines, driving the evolution of the universe in ways we're only beginning to understand. But how? That's a story for the next fact, and trust me, it's going to take us even deeper into the mysteries of these enigmatic giants. Now, let's turn our attention to one of the most dazzling and energetic phenomena in the cosmos: quasars. Imagine an object so bright, it outshines not just stars but entire galaxies. These are quasars, cosmic beacons that light up the universe, and they're powered by none other than supermassive black holes. But how can something as dark and destructive as a black hole create such an incredible display of light? The answer lies in the chaotic, high-energy environment surrounding these cosmic giants. At the heart of every quasar is a supermassive black hole, millions or even billions of times more massive than our Sun. But here's the twist: it's not the black hole itself that's shining. Instead, it's the swirling disk of gas and dust called an accretion disk that surrounds it. As matter spirals into the black hole, it heats up to unimaginable temperatures, glowing so brightly that it can be seen across billions of light years. In fact, quasars are so luminous that they can outshine 1,000 Milky Way galaxies combined. That's like a single flashlight outshining a stadium full of floodlights. Take the quasar 3C273 for example. Discovered in 1963, it was the first quasar ever identified, and it's still one of the brightest objects in the universe. Despite being over 2 billion light-years away, it's visible with amateur telescopes. Its light has traveled across the cosmos for billions of years, giving us a glimpse into the universe's distant past. And all that energy, it's coming from a supermassive black hole at its core, devouring matter at an astonishing rate. But here's where it gets even more fascinating. Quasars aren't just bright, they're also incredibly powerful. The energy released by a quasar can influence its entire galaxy, shaping the formation of stars and even triggering the birth of new ones. It's like the black hole is a cosmic engine driving the evolution of the universe itself. And sometimes this energy is channeled into jets of particles that shoot out at nearly the speed of light, stretching for thousands of light years into space. These jets are so powerful they can carve through galaxies, leaving behind trails of glowing gas. So, while black holes are often thought of as cosmic vacuum cleaners, they are also cosmic powerhouses, capable of creating some of the most spectacular displays in the universe. But here's the kicker: for all their brilliance, quasars are also a reminder of the destructive power of black holes. The same forces that light up the cosmos can also tear it apart. And that's a story we'll explore next, one that takes us to the darker side of these enigmatic giants. Now, let's take a journey to the very edge of cosmic possibility, where black holes might not just shape the universe but end it. Imagine this: what if the ultimate fate of the cosmos isn't a slow fade into darkness, but a dramatic collapse into a single, all-consuming point? This is the idea behind the Big Crunch, a theory that suggests the universe could one day reverse its expansion and collapse back in on itself. And at the heart of this cosmic catastrophe, black holes. Here's how it could happen. Right now, the universe is expanding, with galaxies moving farther apart. But what if that expansion slows down, stops, and then reverses? Gravity, the force that holds everything together, could begin to pull everything back. Galaxies would collide, stars would merge, and black holes, already the most massive objects in the universe, would grow even larger as they devour everything in their path. Eventually, all the matter in the universe could be compressed into a single, unimaginably dense point, a universal singularity. It's like the Big Bang in reverse, a cosmic reset button that wipes the slate clean. But here's the twist: this isn't just a wild idea. It's a real possibility that scientists have explored for decades. The Big Crunch is one of several theories about how the universe might end, and black holes play a starring role. As they grow and merge, they could accelerate the collapse, pulling the universe into a final, fiery embrace. And at the center of it all, a singularity, a point where the laws of physics as we know them break down completely. What would that look like? Well, it's hard to say. A universal singularity would be unlike anything we've ever seen. Time and space would cease to exist as we understand them, and the universe as we know it would come to an end. It's a chilling thought, but also a fascinating one. After all, if black holes can warp time and space on a small scale, what could they do on a cosmic scale? And here's where it gets even more mind-bending. Some scientists speculate that this universal singularity could be the starting point for a new universe. Imagine the Big Crunch as the end of one cosmic cycle and the beginning of another. The universe collapses into a singularity, and then bang, a new Big Bang occurs, creating a brand new universe. It's like the cosmos is stuck in an endless loop of creation and destruction, with black holes playing a key role in each cycle. But here's the kicker: we don't know for sure if this will happen. The fate of the universe depends on factors we're still trying to understand, like the nature of dark energy and the ultimate balance between expansion and gravity. What we do know is that black holes will continue to challenge our understanding of physics, pushing us to rethink everything we thought we knew about space, time, and reality itself. So, as we've seen, black holes aren't just cosmic oddities, they're the ultimate enigmas. shaping the universe on every scale, from the smallest particles to the fate of the cosmos itself. And as we continue to explore their mysteries, one thing is clear: the more we learn about black holes, the more we realize how much we still have to discover. The universe is full of secrets, and black holes are the key to unlocking them. But what does that mean for the future of science and for us? That's a story that's still being written, and it's one that will keep us looking to the stars for generations to come. Now, let's take a moment to reflect on everything we've explored so far: black holes bending light, warping time, colliding in cosmic dances, and even powering the brightest objects in the universe. But as much as we've learned, there's still so much we don't know. Black holes are, after all, the ultimate cosmic mysteries, and some of their biggest secrets remain unsolved. So let's dive into the bonus section, the biggest unanswered questions about black holes, questions that keep scientists up at night and remind us just how much we still have to discover. First, let's talk about the singularity, the heart of a black hole. We know it's a point of infinite density where the laws of physics as we understand them break down completely. But what actually happens inside a singularity? Is it truly a point of infinite density, or is there something else going on that we can't yet comprehend? Some theories suggest that singularities might be gateways to other dimensions or even other universes. Others propose that they could be the birthplaces of entirely new laws of physics. The truth is, we don't know, and that's what makes it so fascinating. The singularity is the ultimate cosmic riddle, a place where our understanding of reality hits a wall. Then there's the event horizon, the boundary beyond which nothing can escape. We've talked about how it's the point of no return, but what's it really like to cross one? Would you even notice as you passed through, or would it feel like any other moment in space? Some scientists think the event horizon might not be as smooth as we imagine. It could be a chaotic, turbulent region filled with quantum fluctuations and strange phenomena. And here's the kicker: what if the event horizon isn't a one-way street? Could there be a way to escape a black hole after crossing it? These are questions that challenge our understanding of space, time, and the very nature of reality. And then there's the big one: could we ever harness the power of a black hole? Imagine a future where black holes aren't just cosmic curiosities, they're energy sources powering entire civilizations. It sounds like science fiction, but some scientists believe it might be possible. One idea is to extract energy from a black hole's spin, using its immense rotational energy to generate power. Another is to tap into the energy of the accretion disk, the swirling ring of superheated gas that surrounds a black hole. These concepts are still in the realm of theory, but they remind us that black holes aren't just destructive, they're also potential engines of creation. So, as we wrap up this journey through the astonishing facts about black holes, let's take a moment to marvel at how much we've learned and how much we still have to discover. Black holes are more than just cosmic oddities. They're windows into the deepest mysteries of the universe. They challenge us to think bigger, to question what we know, and to stay curious about the cosmos. And who knows, maybe one day you'll be the one to unlock the next great mystery about these enigmatic giants. Until then, keep looking up, keep asking questions, and remember, the universe is full of wonders just waiting to be explored. So, let's take a moment to reflect on the journey we've just taken through the mind-bending world of black holes. From their unimaginable density to their ability to warp time and space, these cosmic giants have shown us just how strange and awe-inspiring the universe can be. We've explored how black holes aren't just destructive forces, they're also cosmic recyclers, powering some of the brightest objects in the universe and shaping the very fabric of galaxies. We've marveled at the bizarre phenomenon of spaghettification, where the immense gravity of a black hole stretches matter into thin strands, and we've pondered the mysteries of time dilation, where time itself slows to a crawl near a black hole's event horizon. We've seen how black holes can collide, sending ripples through spacetime in the form of gravitational waves, and we've even considered the possibility that they might be portals to other universes or the key to unlocking the mystery of dark matter. We've delved into the black hole information paradox, where the very laws of physics seem to break down, and we've explored the idea that black holes might not just be cosmic vacuum cleaners, they could also be cosmic archivists preserving the history of everything they've ever consumed. And let's not forget quasars, those dazzling beacons of light powered by supermassive black holes, or the chilling possibility that black holes could play a role in the ultimate fate of the universe itself. Each of these 15 astonishing facts has challenged our understanding of the cosmos, pushing the boundaries of what we thought was possible and reminding us just how much we still have to learn. Black holes are more than just cosmic oddities, they're windows into the deepest mysteries of the universe. They force us to rethink our understanding of space, time, and reality itself, and they inspire us to keep asking questions, to keep exploring, and to keep pushing the limits of human knowledge. As the great physicist Stephen Hawking once said, "Look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist." Be curious, so as we wrap up this journey, let's take that curiosity with us. The universe is full of wonders, and black holes are just the beginning. If you've enjoyed this deep dive into the mysteries of the cosmos, don't forget to like, share, and subscribe for more explorations into the wonders of space. Who knows what secrets we'll uncover next? Until then, keep looking up, keep wondering, and remember, the universe is vast, mysterious, and endlessly fascinating. Thanks for watching, and see you in the next adventure.